Hi everyone, and thanks for joining. Today I'm going to walk you through this hands-on lab available on QA Academy platform, previously known as Cloud Academy, named Security Audit Techniques. I'll read through the description of this lab, then start the lab. The lab focuses on auditing the network security of Linux hosts. You will audit a Kali Linux host and an Ubuntu 8 host that is intentionally configured to be vulnerable to attacks. The techniques you learn apply to all modern distributions of Linux. By including the auditing techniques as part of routine system administration, you can reduce the attack surface of your systems, potentially identify when systems have been compromised, and improve your overall security posture. The local network for this lab is contained within a Hyper-V virtual environment. The hosts that you will audit are virtual machines running in the Hyper-V environment. The lab is designed for the CREST Practitioner Security Analyst (CPSA) certification examination, but is of value to security practitioners in general. Lab objectives. Upon completion of this lab, you will be able to perform network security audits of Linux systems, understand how to conduct commands specific to your auditing needs, generate summary reports of system-wide network socket usage, and identify network sockets being used by specific processes and connections. Lab prerequisites. You should be familiar with TCP and UDP network protocol basics. You can fulfill the prerequisites by completing the OSI and TCP/IP networking models course. So let's see environment before and environment after. So before, after, and let's proceed to start the lab. So we have two steps in this lab. While the environment is loading, I'll start reading through the first step. Auditing network socket statistics with SS. Introduction. Periodically auditing the ports used by your system is part of an effective security strategy. Unexpected connections and listening ports can indicate the system has been exploited and, at the least, warrants further investigation to understand the cause. Modern Linux systems use the socket statistics command to audit the network and other types of sockets. We will use socket statistics to audit a Kali Linux system in this lab step. A socket is an endpoint for communication. In this context, a socket is specifically an IP address, a protocol, and a port. Historically, another tool named netstat was used to perform the tasks in this lab on Linux systems. However, netstat is obsolete on Linux systems, and SS should be used as its replacement. Netstat is still used by Mac OS X systems. Instructions. Once fully provisioned, click the Hyper-V Manager icon in the taskbar at the bottom of the screen to open Hyper-V Manager. Double-click the Kali virtual machine in Hyper-V Manager to connect to the Kali Linux virtual machine. Type root to enter your username before clicking Next. Note, even if the screen is black or has a notification, simply begin typing to enter your username. Type TOOR for your password before clicking Sign In. Click the terminal icon in the left menu bar to open a terminal. The following terminal appears. The root at Kali prompt tells you that you are using the root user on the host named Kali. The flashing white rectangle is your cursor. At the prompt, type the following command and press Enter to list a summary -s or socket statistics SS for the system. SS-S The total refers to the total number of all active streams on the system at that point in time. This number includes more than just network sockets, which are the focus of this lab. It also includes Unix stream sockets, which are used for communicating between processes on the host. The transport table divides sockets into several common categories of Internet Protocol sockets and subdivided based on whether they are IPv4 or IPv6. The INET category includes raw, UDP, and TCP. At the moment, there is only one raw socket listening. The more sockets that are listening, the larger the attack surface of the host. With only one network socket listening, there is a small attack surface. To cause some TCP sockets to be opened, you will use a web browser. Open the Firefox web browser, and wait until the browser appears. In the browser, navigate to http 192.168.0.101 to view a website hosted by another VM on the local network. Reduce the window size of Firefox so you can see Firefox and your terminal by clicking on this resize button in the top right corner, and in the terminal reissue the command to list a summary of socket statistics, ss-s. After loading the website, there are several changes to the summary. The exact changes you see may be different. What is important is how to interpret the data. The TCP line at the top displays 13 connections, of which 10 are established and 3 are closed. The transport table shows the 10 established connections appearing under the IPv4 column in the TCP and INET rows. This makes sense since the website's traffic is served over HTTP, which is TCP port 80. Enter the following command to view more information about TCP and UDP sockets, ss-tuap. The output displays all TCP and UDP sockets along with the process using the socket when a process can be identified by SS. The options have the following meanings. -T display TCP sockets, -U display UDP sockets, -A display both listening and non-listening sockets, -P show process using the socket, the final column in the output. In the screenshot above, there are 2 established TCP connections. Both connections are between the Kali Linux host 192.168.0.100 and VM hosting the website 192.168.0.101. The website is served using HTTP, port of peer, and the port on the local machine is selected from the ephemeral port range for use with short-lived connections. For example, 45226 and 45228. Both connections are used by Firefox. Note: your output will differ from the image. If you do not see any rows beginning with TCP or UDP, navigate to a different website in Firefox and reissue the command shortly after. Attempt to identify the process associated with the raw socket that is listed in the socket statistics summary. The solution is at the end of this lab step. Hint: refer to the manual page for SS. Man SS and summary. In this lab step, you used socket statistics to audit the network sockets of a Linux system. Solutions to view raw sockets. The following command can be used: ss-web. The -w option displays raw socket. The -a displays all socket states, and -p displays the process using the socket. You can see the network manager is using the raw socket. That would be all for this step. No validations here. Let's switch to the hands-on part. You can close this window. You'll need Hyper-V. And here Kali. Let's open the terminal. Let's see if we can use clipboard, type clipboard test to copy paste the code. Seems like not at the moment. So let's type it out manually. Okay, now Firefox, right? Let's give it a few seconds. Let's reissue the ss-s command. Then ss-tuap, another view. Okay, let's maximize this window. Let's see a menu for SS. Okay, let's exit out of here. And let's check out the help. Okay, there's that if needed. And then let's run this solution to view raw sockets. And there's the mentioned network manager. Okay, let's proceed to the step 2. Using SS to audit a highly vulnerable system. Kali Linux is a Linux distribution with a focus on security. There was not much network socket activity due to services running on the system. In this lab step, you will use SS to audit the Metasploitable 2 system, which is running Ubuntu 8 and configured with many outdated services. Instructions. In the terminal, enter the following command to connect to the Metasploitable 2 host. SSH msfadmin at 192.168.0.101. When prompted, enter the following. Are you sure you want to continue connecting? Yes, no, yes. msfadmin at 192.168.0.101's password msfadmin. Issue the following command to view all TCP and UDP sockets as well as process information ss-tuap. There are many more sockets listed on this host. Notice the output of SS will replace the port number with the service associated with the port, for example SMTP rather than 25. If this is undesirable, you can include the -n option to always list port numbers. View the socket statistics summary to see how many sockets are active with SS-S. The output is slightly different on this host, providing a few additional pieces of information than on Kali Linux. The summary table shows that 58 iNet sockets are active in total. Use SS to identify the port that the Kali Linux host is using for its SSH connection to Metasploitable 2. The solution is at the end of this lab step. Summary. In this lab step, you audited another Linux host using SS. The host in this case is much more vulnerable, having many sockets listening. In practice, you would use the results of the audit to ensure that the results matched your expectations. If not, you need to investigate what is the cause of the differences. The processes that are expected to be listening on sockets should be kept up to date with the latest security patches to limit the chances of being the victim of an attack. Solutions to view raw sockets. The following command can be used: ss-t, then grep only SSH from there. SSH is connection oriented and uses TCP, so only the -t flag is required to view established TCP connections. The Kali Linux host will use an ephemeral port, while the Metasploitable 2 host uses port 22 SSH for its port. In the image above, the port is 42734. I think that would be all from the instruction. Let's run these commands. Let's SSH to this Metasploitable 2 host as msfadmin. Okay, now we're not root at Kali anymore, so we have another username and another host. And from here, let's list all TCP and UDP sockets as well as process information. Let's add -n to see port numbers instead of service names. And let's see summary for sockets statistics. And finally, let's run the ss-t and grep SSH to identify the port Kali Linux host is using for its SSH connection to Metasploitable 2. In our case, that would be 56 to 70. And that would be all for this video. Like and subscribe if you enjoyed this one. Until next video, bye for now.